Thank you, everyone. Before I start, I actually would like to give you a push towards getting on this stage next year. Because I have a question for you. How do you think people get to speak in front of hundreds of people? The answer is one conference at a time. I'm a programmer like you. I'm not special in this in any way related to public speaking. But I believe that your voice matters because we can listen to experts all day, but at the end of the day, what they have is just specific views on things. What you have is a very down-on-the-earth, real view on how things happen in your context. And this is a very important message to pass across to other people. So whenever people tell me there's nothing I have to say, well, let me tell you, you have something to say. You have your stories. Whatever happens daily at your work, those are very important, very interesting things that you can share and ask questions or find answers. And if you are afraid to speak in public, know that you are not alone. I was terrified to speak in public 10 years ago when I started. And the way I dealt with it was by going first into small, friendly communities and then going to a bit larger conferences and doing some co-speaking. So I couldn't speak for the first 5 or 10 minutes of a talk. And because of this, I had my pairs starting, and then I would kick in after a while. And 10 years later, I got to speak in front of hundreds of people. So it's possible. And if you are afraid that conferences won't accept you, I have a secret for you. Conferences actually love new speakers. So get out there, write an abstract, copy-paste it to 10 different conferences, and 10 years later, you'll rock the stage at one of these conferences. That's what I wanted to start with. Well, now let us go into the topic today. What I like to speak about is how do we design code without types? And in building this talk, I actually realized what I was trying to do is more of an experiment in minimalism in code. And we'll go into details, and I'm going to show you code, and we can discuss about these things. So first of all, if you're interested in finding the slides, I like to publish them before the conference. So if you just take a photo of this, you'll get the slides immediately. And you can review them and ask questions even later. OK, so because I am here for the first time, and there are many people that I don't know, I thought about introducing myself a little. And Lou did a very interesting thing at the speakers dinner. He asked us to draw a mind map of who we are and kind of exchange with other speakers and discuss on it. So this is who I am. Some people were surprised that I'm reading Batman comics for the first time now. Right? That's unusual, but if you are from Eastern Europe, I'm from Romania, we didn't have Batman when I grew up, so there was no such thing. And I'm doing a bunch of things, but I'm just going to go into a few things that I'm doing today. One is working with a bank for digital transformation. I also worked for another bank for digital transformation last year. And I'm also writing a book, and you'll see some code samples from this book in the talk. And the topic I love the most is software design. And I pulled an MCU on conferences because I kind of went to different conferences with different talks. And then if you look at the playlist, they kind of build up the topic and my views on this. And you can find, if you are interested in the topic, you can find the YouTube playlist on that. URL. So why did I want to have this talk? I thought a bit about how I evolved as a software developer, and I read my first book on computers when I was 10. I didn't get actually to a computer until I was 14 or so, and it was a ZX80 clone. So basically what I started with was BASIC, and then moved to Turbo Pascal C, C++. And back then my question about types was, what are these things? How can I use those? I had no opinion on those. Then as an early professional, let's say 21, 30 years old, I did mostly C#, Java, C++, strongly typed languages. Or, well, not as strongly typed as Haskell maybe, but quite strongly typed. And my stance on time back then was, yeah, they are probably great. I'm using them, they seem interesting. And then I read this book. And this book is mind-blowing. Even if you are not into C++, this book is actually about generic programming. And years later, when I looked into Haskell, I recognized all the things in Haskell from this book. It's basically extremely, extremely interesting. So what this book is showing is how you can use the type system to write code that is correct, is proven correct at the compile time. No need for tests, no need for everything. You cannot write code that doesn't work by using those strong types. And it is indeed something extremely interesting. And now, let's say later, 30 to 40, I started looking into other languages because I got into software craft movement, and I started looking at how can I get out of my comfort zone? What other things can I try? And I started to try various other programming languages and figuring out, what are some of the assumptions that I make and what can I do to prove them right or wrong for myself. And so I kept trying to move out of my comfort zone. Because this, to me, when I'm looking at the Manifesto for Software Craftsmanship, or software craft, as we call it now, it's the most important part is raising the bar. All the other things are very useful, but what I'm most attracted to is raising the bar. So right now, what I've evolved into is more like a code designer thing. What does this mean? It means that I believe in a few things. I believe that the code is the design. And I don't mean this as a metaphor, I mean this as a very pragmatic, real way. We are writing code that is basically the blueprint used by a compiler to build the actual product, to mass manufacture the product. And so then what I'm looking at is how can we build the code structures, how can we organize the code such that we have what we want from it. And what can I use to solve problems as quickly as possible? And this is when I started noticing, because my mindset changed a bit. As a programmer, I loved writing code. But when I think as a designer, I think about what is the problem that I'm trying to solve, how can I solve it as fast as possible? And one of the things that I decided to try out was minimalism. Minimalism is a design current, right? It's known, but how does it apply to code? How does it translate to code? So there are a few things that we can look at. One of them is, yes, I love writing code, but in reality, what happens is that custom code is really, really expensive. It's expensive to build, it's expensive to test, it's expensive to make work. And then once you thought that it works, a library update comes, or Java changes version, or something else, and it breaks your code. And then you need to go back and work some more. It requires a lot of maintenance, right? Then another thing that happens is the more lines of code you have, the more bugs you are likely to have. It doesn't sound that, I mean, probably it sounds quite natural once you think about it. Another thing that I notice is the smaller the code is, the less cognitive pressure we have. It's much easier to understand code. It's much easier to change it if it's small. So, without actually realizing, I started doing the experimental minimalism, and I will focus on optional types, but there are a few other things in here. And what I mean by optional types, I mean a few things. First, the type is not specified unless it is really important. I don't mean completely no type, but sometimes it's important to have type. And you'll see in our example, it's if you have a web application, I need to validate the security aspects of the input and so on, and that's where types are really useful. Maybe I need to link it to the storage, and that's again where the types are useful. But in the middle, I don't actually need most of the types. I don't want to do casting. I don't want to think about the types. What I'd like to think about is more about what are the capabilities that I need from the variables that I'm using. And when I started, I expected a few things. I expected bugs. I expected to have some weird problems. I expected people who were telling me, and I agreed at the time, because I don't have types, I will need to write more tests to cover for the fact that I don't have the type checking and all that. And maybe difficult to understand code. But the thing is, what I got is different. I didn't write as many tests as I expected to write. I didn't have to compensate for the type system. And the code got cleaner, smaller. Now, part of it, and that's one of the challenges when making an experiment, part of it may be because of the technology. Part of it may be because of the language. But maybe some of the things in the language are actually enabled by optional types. And I will let you judge for yourself on each of these issues when I'm showing you the code. So I'm just going to show a few code samples from a platform that we built, eventrix.co. It's not perfect by any means, and we learned a lot of it. And before that, let me go a bit into minimalism. So when we talk about Groovy, Java versus Groovy, we use Groovy in this. Groovy is a JVM-based language with optional types. And the first things I realized was, okay, we used to write user or the time name a lot of times. And I also realized that I was hating semicolons with really big ardor. I cannot stand semicolons anymore unless I really have to write them. And again, you can make your own judgment. I'm showing a few samples. Then if you compare things like lambdas in C++ with lambdas in Groovy, you notice a lot of things there happening. So you have the square brackets in the beginning, which if you are not a C++ programmer, will have no idea what they are. They are actually meant for capturing variables. And you need to have semicolons and return statements. The alternative in Groovy is just much smaller, much cleaner. At least it adheres to my definition of minimalism. But there is some magic there, right? So you have it. What is it? You need to know what it is in this case. And it is the only variable, the only parameter of a lambda by default in Groovy. If you want to do something like getting the list of names of users in C++, by the way, you can do this with optional types now in C++ as well, which is quite interesting. You have to write this, while in Groovy is something like this. Because they recognize, oh, we need to project a lot of times, we need to project a list of variables to their properties. So yeah, why not have an operator for it? And if you need to do something like first name plus last name, some kind of combination like this, this is the version in C++, and this is what you would get in Groovy, like the simplest one. So to me, this is cleaner, it's smaller code, less pressure, less symbols to understand, less symbols to read. Is this enabled by optional types? Maybe, maybe not. It's also enabled by complex. C++ is a very complex language in a very long history, and you can see why. So now let's look a bit at optional types. I need to change my display. Okay. Right. So I'm going to start with an example of a test in Spock. Spock is a Groovy framework for testing. And it has a very interesting feature, which I really love. You know, when you want to write data-driven tests in any other language, you need to kind of make a constructor. In Java, it's a whole thing. You need to actually read through the documentation to figure out how to do this. You need to write a constructor for the class, for the test class, and then get the data in there. But what I really want is a table. And they recognize that. And what they said is, oh, how about just having a table? It doesn't really matter. And again, this is a feature that's enabled by a structure of language that's less strict. Because if you had a very strict language structure, something like this would never compile. So maybe it's good to have a less strict language structure. Another thing that you will notice here is something like, this is called a command in our code. What it does is when you call the controller, it immediately delegates to the command. And it automatically binds the query parameters to the values there. You notice that we have types here. This is where I was talking about, you know, we should have types in some places because they support our validation for security. But then immediately afterwards, you don't have types anymore. And you can see how this goes. So for example, in controller, I have no idea what types these are. And I'm showing you this just to get an idea of how the code looks like. These are just picked out of the code for the sake of presentation, but most of our functions are like this. Right? They are very small. The names are very clear, and I'm going to come back to this. And they have a very clear goal, a very clear purpose. And then you have something like this, which is, this is a query. This would return values from the database. And again, we don't know what the types are here. And I'm showing this just to give you an idea of how such code would look like, right? I'm going to come back to this a bit later. Okay. Okay, so we were... So this got me, once I saw many samples of code like this, I started asking a few questions. And these are, let's say, the most interesting part of the talk. The first question was, is it worth to have a cost of abstraction? And let me tell you a story. I love Haskell as a programming language. It's really neat. It's intellectually satisfying. It feels like once you solve a problem in Haskell, it's just solved and it's there, and you can basically, conquer the world with it. However, I once paired with a Haskell programmer, and pretty good guy. I trust his skills. And my question was, okay, let's try to build a web application using Haskell. To which his first reaction was surprise, because apparently Haskell programmers don't do web applications. I don't exactly know what they are doing, but apparently not that. And then when we started, we got a library. I think it was Hapstack. It was a few years ago. We looked at the library, tried to build something. It took us about 2 hours to figure out the first compile error message and how to deal with it. And what this shows to me is that, yes, maybe you can have something that is proven at compile time that it's correct. And that's amazing, really. It's really a feat. But what is the cost of it? The cost of it is that you need to go into abstractions. You need to get higher and higher level of abstractions. And then if you come back 6 months later, or if you try to reuse that code, how easy it is for you to get back into it. And I remember the same feeling from reading Andrei Alexandrescu's book on generic programming in C++. All the code samples are amazing, but I have no idea how to use them again. Well, I actually don't remember how. I just remember the feeling that everything was awesome there. So there's a question. There is a cost of abstraction, right? Do we want to pay this cost, have more types, or do we want to not pay this cost and deal with it? And this is an interesting question to think about. Another question is strong typing a form of strong coupling? And I'd like to define strong coupling because there are many, many definitions out there, but the way I think about it is in terms of code evolution. I know that I have strong coupling whenever I need to change in one place of the code, I need to change in 10 other places of the code. This is what it means to have strong coupling. So if I'm doing something like this, let's say I want to confirm an email, and it gets an int user ID, right? The code is pretty simple. It does what it's supposed to do, whatever. But then the next question is, if there are some domain-driven design people here, they would say, no, not ID, not int, right? You need to have maybe a specific type for it. Maybe your company buys another company that uses another kind of ID, and you need to kind of abstract those two IDs in one thing because you need to unite the two platforms. Maybe you need to do some kind of things. But it's absolutely okay to start with a simple type, with an int, with a long GUID, whatever, and then to change whenever you need to. But now if I want to change the type, how many things do I need to change? I need to change the user, which is normal, because if the ID changes, yes, it should change there. But why do I need to change the confirm email function? It doesn't make any sense. These two are different concerns. And in this category, we can put many, many other things that use an int user ID. If I don't have the type, I don't care, it just works. It works because with a few specific constraints, right? I need to have a user.get method that receives the user ID, whatever that is, and I need to be able to, I don't know, do some validation with it and so on. But I don't care what the type is. I don't need to change as much, right? So there's a distinct advantage in having this. There's looser typing. There's looser coupling, right? And I think we need to pay attention to this. Another thing that we notice is I kept thinking, why is the code easy to read, even without types? Because types provide a lot of useful information when you read, especially when you read documentation and you're trying to figure out how to call some kind of method, right? How do you know what you pass in? And usually it's because you know the types. That's the first hint, and then you have more hints from the actual documentation. But the thing is, if you don't have types, what you are left with is names. Names become much, much more important for your design. And I think we can all agree that names are actually a very important part of your design anyway, right? So maybe it's an interesting exercise to make, at least. So if you look at this, every line here is very clear. Every variable name is very clear. The function name is very clear. And maybe you don't know what UserDB service is, but we do because we have a specific design pattern for it, and I'm going to go into details a bit later. Now, another thing, again, once you remove the types, what are you left with? You are left with names and something else, the contract. What is the contract of your class? What are their capabilities? When I say user ID somewhere, what do I expect from user ID to have? And since we have some time, I can actually show you a sample in C++ this time. One of the problems that I like to tackle, especially for functional programming, is the so-called tic-tac-toe result. So basically, you get a board, and you need to tell me what is the current status of the board. Did anybody win? Who won? Or is still a game in progress? Something like this. And it really works for functional programming, if you want to check it out. But what I want to show you is actually how this whole thing works together. By the way, this is not actually working code. I just picked out a few things to show. So if you see things that are not in the code, that's the reason why. So if we have something like this, we'd like to know that X wins. That's basically what's happening with this tic-tac-toe board. So what does X wins means? It means a bunch of things. Basically, it takes what we are doing is we are getting all the lines, all the columns, all the diagonals into a list of things, and then we are checking, is any of these things filled with X? That's the basic algorithm. But now what I want you to pay attention to is the line. Because in all this code, the line is auto, which basically means I don't know what type this is. That's what's, the C++ keyword for I don't care about the type. And, well, actually the coordinate, right? So in order to get the line, and to get the line, the columns, and the diagonals, what I'm doing is I'm getting the coordinates and I'm projecting those. And so what you see about the coordinate is it has two things. It has this thing, which is a pair of line index and index. And then it's used into another place here. Oh, sorry. Well, you can see that it has a first and a second. And if you look at the type, it's just a pair of int and int of coordinate, which doesn't mean that you cannot change it later. So basically, the contract of the coordinate is used in two places. And those are the only two places where I care what it's about, right? But it does have a contract, and I need to know it. And this is one of the lessons I learned. We need to be very aware of the contracts when we are doing optional types. And there are various ways to do this, but one of the simplest one is just have a very clear definition of what every item in your design means. Okay, so I was talking before about the DB service. We did got into higher level design patterns. So we basically started to get, this started as my fear that whenever we are using an MVC framework, what happens is that what you put in the model is very clear, what you put in the view is very clear, and everything else just go dumped into the controller, right? That's how MVC applications tend to evolve. And so I wanted to separate these classes into more types of classes. And this shows that we actually have some kind of type system, but it's more loose and more based on discipline rather than on the compiler. So we have things like, of course, model. We have a query, which we've already seen. We encapsulate getting specific data. We have a DB command, encapsulates saving data to the database. We have a DB service, which kind of blends from controller command, then you go to a DB service. Just to make multiple operations in the database. You have a business service, usually for things that are, let's say, more like a business flow. And you have a command. And these are not perfect. But I'm just showing you that when we haven't used optional types, we did actually use something else, right? We used the higher level concept of these things. And you can see those in the names. Everything is named according to a specific scheme, is tested according to a specific scheme, and so on. Okay. So, my conclusion, and I would be interested to hear your conclusions, because I'm not trying to say that this is, a closed subject. It's more like an invitation to chat some more. My conclusion is that minimalism exerts a positive pressure on design. And I believe that at least as an experiment, if you take it as a kata, if you take it as an exercise, try to remove as many things as you can from your code. Semicolons, parentheses, types, and see where this takes you. And just, it's a good exercise to make. I strongly encourage you to get out of your comfort zone. This is how we learn. So without types, how do we understand the code? Well, it needs to be smaller, because if I'm having a 500 lines method, I cannot understand it with the types, but without types, it can even be more complex. I need to have better names. Because when I don't have the type, I need to carefully consider what information I give to myself or to other people who are using this. I need to have clear responsibilities. If a function does 10 different things, then how do I know? If I receive 20 different parameters and I don't have the types, how do I know what to pass in? I need to have clear contracts. I need to know what each of these classes is actually, of these objects is actually doing. And I also need to have tests that show me how to use this thing. Right? So now, in the end, do I say we should always go to optional types? Definitely no. I don't think it's, I don't believe in one solution for every problem. Instead, I want to look at problems and I want to find the best solution that fits my current problem. And I believe that there are problems that can be solved extremely well with strong types validation at compile time. Think about stuff like, I don't know, mathematical simulation, physical simulation. We have customers that are working on simulating how sound propagates inside of a building. You have a model for that, you have an algorithm, you have experts who tell you how to do that. If the model changes, I assume it just changes, drastically. I mean, I probably need to write another type of simulation. So in that situation, if your problem is very clear, very condensed, mathematically oriented is a good example, then maybe, strong types are exceptionally well suited to deal with it. But if I'm expecting change, if I don't know exactly what I'm doing, if I'm developing something like a web app that can go in that direction or in that direction, and where customers are asking from me a lot of things, maybe I don't bother adding strong types in the middle of the system, but only at the edges. I don't know. It's up to you to decide. I believe this brings us to more changeable code. And one of the common things that I hear is, I want the compiler to do as much for me as possible. And that was an interesting thing. I mean, yes, I'd like that. But on the other hand, maybe I want to write the code that makes sense and let the compiler figure it out. So I don't believe these two stances are necessarily mutually exclusive. They probably fit different contexts, and we should pick the one that fits better our context. So I'm going to ask a few questions, but after this talk, I will be in the lunch area. I have some nice stickers to give away. So I invite you to chat, ask questions, show me code. I've been for 20 years in this industry. Maybe you want to find out experiences or, I don't know, learn how we did the first code retreat. That's an interesting story. Thank you.
Thank you, Alex. That was awesome. We have a bunch of questions submitted to Slido. There's a lot of love for types, so let's get started. Isn't the lack of types make it impossible to refactor safety? The compiler makes you change a lot of places in the code, but the dynamic language, you still have to change all of them, except no one tells you.
Yeah, so this is indeed one concern. My experience has been that we used Groovy with IntelliJ, and it's been a really nice fit. It worked quite well, because the tool again stepped up and figured out ways how to help. there were still some situations where we needed to do manual refactorings, but we had tests. So we knew immediately if something was wrong.
All right, thank you. What do you suggest to ease the complexity of maintaining a code base that's written in a dynamically typed language?
Well, I think I touched on a few things. So first, naming is very important, small classes, small, basically clean code. That's the first thing that we need to do. Then split it into smaller components. If you have a large code base, and that's actually what we did, we split it into separate modules. You have in Grails, you have the concept of plugins. So we extracted a bunch of plugins, we extracted a bunch of libraries that had very, very clear goal. But that's not new. I mean, it's the same thing that you do for typed languages. You need modular code, proper design, clean code, and tests. So.
All right. Anonymous asks, how about debugging pain when an unexpected type being returned in the end of a process?
I have never experienced this. So I expected this to happen. I was bracing for it. It never happened to us. I don't know whether it was because of tests or whether it was because of the structure that we put in place or because of the collaboration. I have no idea why, but we never had this problem. So we never actually debugged the code. I haven't touched the debugger.
Fair enough. What about from T? Lack of types does not mean loose coupling between components. You just do not know about the coupling, right?
Well, not really, because I showed you in the examples, of course you need some kind of coupling, right? But the coupling is more on constructor and some of the behaviors that you need. And usually you don't need all the behaviors in all the places, right? So that's why I believe there's looser coupling. I don't know if I'm making sense, but that's the best answer I can come up with.
All right. So what about TypeScript? It's great.
I have never used TypeScript. I'm sorry. It's on my list, but I'm writing a book and I don't have time to try on new languages.
It's great. I answer it for you. And when you think about strong typing with good type interference, for example, F#.
Strong typing with good type inference. I mean, again, I don't have a strong experience with this. I haven't used F#. I've seen some code samples. I'd be willing to give it a try. That's the best I can say. I don't have an opinion right now.
All right. Let's pick one more. One idea is to use types only in selected places, for instance, at validation time or at compile time. Clojure lets you do that. What do you think about that?
Well, I think this is in line with what I've been talking about. There are places where we can use types to enhance our validation or security or connection to databases or things like that. So why not? It sounds like a good idea. I haven't tried this in Clojure. It'd be very interesting to see a sample.
All right, super cool. Another round of applause for Alex. Thank you so much.
Thank you.